Sir, I don't think I'm getting the answer. So it's better if we discuss.
Now I am going to discuss the question. Question talking about a train. Train will start from rest from railway station P, accelerate uniformly at simple acceleration, certain distance and decelerate uniformly at B, another few meters and come to rest at station Q. So motion not yet talk about the uniform velocity. So then we have to assume only acceleration and decelerate only. This is the graph. And the gradient should be A and B. Like acceleration A, deceleration is B. This should be the maximum velocity. V ms minus 1 t seconds. So you should be able to rename the both axes. This should be the graph, right? The next case, the distance between PQ is 4 meters. Therefore, area under this graph is how much? 4 kilometers. But I'm going to write down as 4,000 meters. Because I have write down in SI units. And time taken by train is 4 minutes. 4 minutes. But I am going to take travel time during acceleration is how much? T. Total time is 4 minutes means 240 seconds. So therefore, the remaining time will be 240 minus T. Right? So this is the initial case of the graph. We're going to find the maximum velocity. Yes. So I am going to consider the area under the graph. Area under the graph is 4 kilometers. The displacement done by the graph is equal to area under the graph. So this is a triangle half area base 240 into V. V is how much? 4,000 meters. 120 V equal 4,000 divided by 120 ms minus 1. This is the maximum velocity. This is the maximum velocity. 4,000 divided by 120. Right? Area under the graph is should be equal to displacement done by the train 4,000 meters. So half 240 into V is equal to 4,000. 120, 2 and 1, 240 will be cancel it off. 4,000 divided by 120 is equal to displacement done by the graph. How many fours? 3. V equal 33.3 ms minus 1. 33.3. Is asked to show that 1 over A plus 1 over B equals 7.2, right? So I am going to take this time is T1 and T2. The displacement done under the acceleration is T1. Move under the deceleration is T2, right? So A is equal gradient V over T1, V over T1, and B is equal to V over T2, V over T2. So then like here T1 is equal V over A, T2 is equal to V over B. So then T1 plus T2 is equal V over A plus V over B. T1 plus T2 means 240. V is common factor 1 over A plus 1 over V. So then V is how much? But V is 100 over 3 is 240. V will 100 over 3. 1 over A plus 1 over B. 240 into 3 divided by 100 is equal 1 over A plus 1 over B. You know 3 over 240 means 720 over 100 means 7.2 is equal 1 over A plus 1 over B. Here is the answer. Right? This is the next question. Do the question now. So I am going to discuss the first three parts of the Roman number 1. Multi-story building. Part 1 is very popular. There's electric motor and braking system in the elevator to maintain constant acceleration as well as the constant deceleration within 5 times interval. You can accelerate when time decelerate when time 5 seconds each, right? VT graph is provided. Acceleration will last, you know. Acceleration is equal to the gradient of the graph, you know, 0.4 ms minus 1 over 5 seconds. So if you're going to find out the gradient, now write down, you have to substitute the values along with their units, right? 0.8 ms minus 2, right? Understood?
Yes.
Yes, sir.
Yeah, he is correct, right? The next case, determine the distance move under constant velocity. What is the height of each flow?
3 meters.
How much?
3 meters.
3 meter, right?
3.
So therefore, area under the graph would be how much? 3 meter. Next. So we know area under the triangle is how much? Half 5 into 0.8. 0.4, eh? 1 meter is 1 meter is.
Yes, sir.
Yeah. According to the symmetry of the diagram, you know, acceleration and deceleration both are equal. Also 1 meter. Therefore, remaining should be how much? 1 meter.
So wait, isn't it 2 meters?
Now, may 5 into 4 will
2
be 2, no?
meters? Yeah.
This is 1 meter.
Yeah, got it.
In your answer, you have to draw this diagram and you have to calculate displacement done under uniform acceleration, blah blah blah. Displacement done under uniform deceleration, 1 meter, 1 meter. The total displacement 3 meter, and on 3 meter minus 2 meter is much equal to 1 meter. Understood? We have find out your
Yeah.
answer.
Yes. Yes.
The next part will ask to find out the T naught value. So I am going to take this time difference is T. Time taken to moving with uniform velocity, I am going to define as T. So area under this rectangle block should be equal to 1 meter. So therefore 0.4 into 4 into T should be 1 meter. Therefore T is equal to how much? 1 over 0.4, 2.5 seconds. So therefore, T naught now should be how much? 7.5. Understood? You know the difference will be 2.5. And this time will be how much? 12.5 T seconds. Understood?
Yes.
It should be 7.5 and 12.5. Five-story building, right? Five-story building. This is the ground level. First floor, second floor, third, fourth, fifth.
Also.
මෙන්න මේක travel කරලා තිනවා ඊට පස්සේ මෙන්න මෙතන 1 minute ඉඳලා තමයි ඊළඟ කැලේ ගිහින් තියෙන්නේ. Understood? Right?
Yes, sir.
Yeah. Now try to understand the logic behind that, right? Whatever the motion, now you can understand. You have to understand. Now the lift is at the bottom, ground level. මෙතන ඉන්නේ. At once it is moved up to its fourth level. Fourth level. Fourth level at ගිහින් තියෙනවා. ඒ කියන්නේ what's the total displacement is how much, friend? 3, 6, 9, 12. Understood? At once it moved 12 meters. तर පුතා මේ graph එකේ ඉන්නේ මෙහෙමයි එකක්. Understood? මේක පිළිගන්නවද? Understood?
Yes, sir.
They have mentioned it is acceleration is only belong to 5 seconds. Topper by accelerate වෙන්නේ. මම කියනවා time taken to moving with uniform velocity is how much? T. Let's see. You know we have already calculated the area under the whole graph is how much? 12 meter. Area under the whole graph is how much, when? 12 meter. But we know we have already calculated displacement done during the acceleration is how much? 1 meter. And also displacement done during the uniform deceleration is also how much? 1 meter. Therefore, area under the graph is how much? 10. Area under the, sorry, displacement done during the uniform velocity is how much? 10 meter. Then I can find out the value of T, you know, 0.4 into T. Area under the rectangle, 0.4 into T is how much? 10 meter, right?
Yeah.
And T is how much? 100 over 4 is how much? 25 seconds. And you know, here will be how much? 30. This should be 35. Agree?
Yeah.
Then they have mentioned 1 minute rest. When a rest time and a 35 plus 60 is how much? 95. Agree?
Yes.
Then it will start to reach its top. And this is similar to the graph given in our paper. You know, the time taken for whole motion is how much? 12.5 seconds, right? Understood?
Yes.
Again, 5 seconds taken for acceleration. Here will be 100.2.5, 107.5 seconds. Understood it?
Yeah.
Yes, sir.
Clear? You have to understand time taken for, sorry, displacement done during its first 4 seconds. 4 seconds is how much? 12 meter. The area under trapezium is 12 meter, but you know, displacement done during uniform acceleration 1. Here also 1. Therefore, area under the rectangle is how much? 10. Using the area, I have time calculate the time taken during to taken for the move with uniform velocity 25. Now 5, 30, 35. Rest 1 mean. 1 mean means how much? 60 seconds. 30 plus 60 will be 95. Further 5 second acceleration, 2.5 uniform velocity, further 5, 107.5 seconds.